Hello! This video is to show you how to use the quadratic formula to find roots and how to factor to find roots and why those methods are very similar. This is a long video, but each question reveals a new piece of the puzzle around solving quadratic equations. So some vocabulary distinctions before we get going. Notes aren't going to be necessary, but could be quite helpful. So I want to first talk about the difference between a quadratic formula and a quadratic equation. So some vocabulary distinctions before we get going. Notes on this page aren't necessary, but they might be helpful. So the first thing I want to distinguish is the difference between the quadratic formula and a quadratic equation. The quadratic formula is the one that we talked about last week, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, and we're going to explore that a lot more. A quadratic equation is any equation that comes in this format, ax squared plus bx plus c, where a, b, and c from here are the a, b, and c over here, and that it's some number x squared plus some number x plus c. So the difference is in a quadratic equation is actually an equation with an equal sign, and a quadratic formula helps us find the zeros or the roots of the equation. Something that I've noticed is a little bit tricky is the difference between x-intercepts and y-intercepts. So an x-intercept on a grid is the horizontal place where the curve crosses the x-intercept. So for example, here there's an x-intercept at that spot and an x-intercept at that spot because they cross the x-axis at that point. And the y-intercept is the same thing. The y-intercept is where the curve crosses the vertical axis, the up and down axis. Now my axis isn't perfectly straight, but I hope that you get the idea. The difference between roots and x-intercepts, there is no difference. So when I'm talking about these points right here, they're called x-intercepts. They're also called the roots of the equation. So we can label them x-intercept, or we can call them roots. And I like to call them roots because it's a much simpler, much faster than remembering x-intercept, and that's a lot. And roots and a solution. A solution is where the equation is true. So if we say that 0 equals 2x squared, then the solution is when x equals 0. It's the value that makes this true. Roots are when the function equals 0. I could have a solution that's like 2 equals 2x squared, in which that's not necessarily a root because it's not 0, but it is a solution. I could find a solution. So there's the difference in some really specific vocabulary. So we're first going to talk about how to factor to solve a quadratic equation and then identify the roots. What's really important here is that our function is in the proper format. Right now, it is ax squared plus bx equals some number, and we need it to be in the proper format. So we've got to do a little bit of solving here, which means that we've got to subtract 12 from both sides, so we get 3x squared plus 16x minus 12 equals 0. It's really important that it equals 0 because then we can use the zero product property. When we're factoring, we're going to use our factoring method, which is we're going to take the boxes and we're going to find values that multiply to, let's see, negative 36. And I'll talk about why that number in particular in just a moment again. And that add up to 16x. So remember, our diagonals have to multiply to be the same thing, but these two in particular have to add up to 16. So I'm thinking about, okay, what needs to multiply to be those two values? So 3 times negative 12 is negative 36. And we're going to think of all of the possible combinations. So 1 and negative 36, no. 2 and negative 18. No, oh, hey, that gets me really close. This gets me negative 16, and I need positive 16, so what if I swap the negatives? Negative 2 and 18. Yep, that does it. So one of the values here is negative 2x. The other value is 18x, and we're going to factor, find common factors. In the top row, a common factor is 3x, which means that on top it has to be 6. And 6 times negative 2 is negative 12. And last but not least, 3x times x gets me 6. So the factored version of this equation right here, this quadratic equation, this is in standard form. The factored form version is x plus 6 times 3x minus 2 equals 0. It's the same thing, just written in a different format. And to find the roots, we're going to use the zero product property. Remember, that means that either this is 0 multiplied by whatever equals 0, or this is 0. 0 times whatever that's going to be equals 0. Anything times 0 is 0. So we're going to say, okay, x plus 6 equals 0, or 3x minus 2 equals 0. And we're going to do a little bit of solving here. Subtract 6, so x equals negative 6, so that's one option. Or, solving for x, so plus 2, 3x equals 2, divide by 3, x equals 2/3. So, one of these two answers is correct, but these are our roots. Go ahead and pause the video if you need to write this down, because we're going to use this information later, and we're going to show you how to do a different way. So we're going to do the same problem, but this time we're going to use the quadratic formula to solve the quadratic equation and identify the roots. It's really important. This is in standard form because it's some number x squared plus some number x plus or minus some number. And I'm going to try and be really explicit about this, that the value of A is 3, the value of B is 16, and the value of C is negative 12. And that's coming from the A, B, and C here in the equation. We're going to use the quadratic formula, and I'm going to start by writing it. So the quadratic formula is negative B plus or minus the square root of B squared minus 4 times A times C, all of that divided by 2 times A. And if you don't have this memorized, be sure that you write it down somewhere or have easy access to it. And all I'm going to do here is anytime I see A, I'm going to replace it with 3. Anytime I see B, I'm going to replace it with 16. And anytime I see C, I'm going to replace it with, ooh, that was a bad negative 12. Negative 12. Anytime I see C, I'm going to replace it with negative 12. Oh, I'm going to backwards there, and I forgot the A. The A is right there. All right, so anytime there's a B, I'm going to replace it with negative 16, or replace it with 16. So instead of x equaling B, we're going to say x equals negative 16, because B is 16, plus or minus the square root of 16 squared minus 4. I'm going to wrap everything in parentheses, and you should too. 4 times A is 3, times C is negative 12. We got to put that negative in there as well. All over 2 times A is 3. And this is a game of just simplifying, so I'm going to go ahead and do that. X equals negative 16 plus or minus the square root of 256, that's 16 squared, minus 4 times 3 times negative 12 is negative 144. All over 6. And there's a double negative there. I want you to pay attention that yes, it's okay to have a double negative, because 4 times 3 times negative 12, that's negative 44, and the minus is also part of that. So x equals negative 16 plus or minus the square root of 400 divided by 6. And I'm going to bring it up here. So that means that x equals negative 16 plus or minus the square root of 400, I put it into a calculator, ends up being 20 over 6. So this is where a lot of students get stuck because it doesn't look like you can simplify it much anymore. But take a look, this plus or minus thing there, that's really critical because it's actually two answers here in one. So we're going to actually split it up. We're going to do the negative 16 plus 20 divided by 6. And we're going to do negative 16 minus 20 divided by 6. And with some simple solutions, this ends up being negative 16 plus 20 is 4 over 6, and that fraction reduces to 2/3. So x equals 2/3. That's one of our answers. And if we do the other side, negative 16 minus 20 is negative 36 divided by 6. That fraction reduced is negative 6. So x equals negative 6. So these are the same answers as before, which is important because it was the same equation. So the same equation should always reveal the same roots. Now that we know our solutions are x equals 2/3, x equals negative 6, the roots are the x-intercepts. So what I'm going to do is graph the roots, or the x-intercepts. And remember that one of those x-intercepts was 2/3, and the other x-intercept was negative 6. Now on my graph, we're not going to graph anything other than the x-intercepts because I want you to see how that works. And remember, the x-intercepts is where the curve is going to cross this line. When we look at this, where is 2/3? 2/3 is positive. It's not quite 1, but it's not quite 0. So it's about 2/3 of the way between 0 and 1. And where is negative 6? Negative 6 is really right on the graph. It ends up being right there. So eventually, in the next couple of the units, we're going to be graphing, and our quadratic is going to go through those 2 points. It's really important that we know where they're at. We're going to explore a lot more. But when you graph the roots, you're finding the x-intercepts. And the x-intercepts are the roots of the function, and they go kind of where you predict, on the x-axis. So we're going to explore one more problem, or a couple more problems. I know this video is long, just stick with us. Each piece reveals another layer of the quadratic function formula. So we're going to start exploring how to factor this, and it's already in my standard form, so I can just jump right into factoring. So I'm looking for things. Remember, the diagonals have to multiply to the same thing, but these two have to add up to 7. So 4 times negative 49 ends up being negative 196. And just like that, with movie magic, we've got all of the factors. It did take me a while to get these, so just know that it takes time, and I fast-forwarded to save us some time. So now we're looking at all of the factors. All of these things multiply up to negative 196, but which pair adds up to 7? So we've got to go row by row and find out. So we got negative 195 and negative 96 and negative 45 and negative 21, and this ends up being 0 and 21 and 45, 96 and 195. Well, shucks, none of these pairs add up to 7. That means this is not factorable. And to find the roots, we have to use the quadratic formula. So when things aren't factorable, we have to use the quadratic formula. So to use the quadratic formula, we're going to use A, B, and C. We know A is 4, B is 7, and C is negative 49. And we're going to use our quadratic formula, x equals negative b. So the x means that the x-intercepts, negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And the x goes in there, and negative b is 7, plus or minus the square root of 7 squared minus 4 times a is 4, and c is negative 49, all of that over 2 times a, and a is 4. Okay? And all I'm doing is simplifying here. Negative 7 plus or minus the square root of, I'm going to do everything in a calculator that's underneath the square root. So that ends up being 883. So that was 7 squared minus 4 times negative 49. All over 2a, that's 8. And from here, it looks like we're stuck. Well, actually, I can take the square root and get a value. So negative 7 plus or minus, that ends up being 28.8617 all over 8. Well, we're stuck. Remember, we've got the two values. The positive version, which is negative 7 plus 28.8617 over 8. And we have the minus version, which is negative 7 minus 28.8617 over 8. And just simplify these fractions. So when I put this into a calculator, I get 2.7327, and down here I get negative 4.4827. So these are our roots, and they're funky looking. They don't look really nice. And now we're going to look at how to graph these. Just a reminder, it's just how do I graph the roots of a function on a grid? So remember, for this, one of our answers, our x-intercept, was 2.7327, and the other one, our answer was negative 4.4827. Now, if you do this by hand, it's not going to be perfect. And I'm going to highlight these so that you can see. I'm going to do one in red, the other one in blue, so you can see that when I graph them. Now, 2.7 is higher than 2.5, but it's not quite 3. So we're going to graph it at 2 and about 7.3. It's not going to be perfect because we're doing it by hand, and our other x-intercept is going to be at negative 4, and negative 4, not quite negative 4.5, so it's a little bit less than 4.5, and that's our x-intercept. Eventually, we're going to be graphing these so you can see, and I'm just going to kind of do a rough sketch. It's going to go through 1, it's going to go all the way down and around, and this is not perfect, it's just a rough sketch, but see that when you graph them, they're going to go through the x-intercepts. So we've talked about what happens and how to graph something that works, but take a look at this graph. This graph does not actually cross the x-axis, and so it doesn't have x-intercepts. Here's an equation. This is an equation that actually represents this picture. What do we do if we don't have x-intercepts? Well, first off, I'm going to tell you that this thing is not factorable. We cannot factor this function, and that's just a given for now. You might need to explore and figure out, hey, this is actually not factorable as you go. But you can use the quadratic formula, and you're going to get something called complex roots. So our a again is 7, our b is negative 10, and our c is 6. We're going to write out the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2 times a. And we're just going to plug and play. So our b is negative 10. It's a negative. Notice, this is critical. Notice that b is negative 10. But it's the opposite of b. So it's the opposite of negative 10. So there's a double negative there. Plus or minus the square root of negative 10 squared minus 4 times a times c. and I'm just replacing a and c with the numbers, all of that divided by 2 times a. And a is 7. And simplifying, double negative on 10, negative times a negative is a positive, so we get 10 plus or minus the square root of 100 minus 168 all over 14. And then x equals 10 plus or minus the square root of negative 68 over 14. Now, you might say, what's so funky about this? You go ahead and try in a calculator to type in the square root of negative 68. It's going to give you either error, or it's going to say not real root, or complex root. It's really important that you see, remember your middle school teacher said you can't take the square root of a negative number, and this is why. Because if we think back to our roots, this grid is not going to show up. Remember, it exists above. It doesn't have x-intercepts. So we're going to say this has complex roots. If we had more time, we would go into this a little bit more in depth, but this does not have real roots. So we're going to say no real roots. It has something called a complex root, and you can explore that a little bit more later on. But it does not have real roots because it does not cross the x-intercept. And you'll see that in the equation if you don't have a graph of it beforehand. You'll see that because you'll end up being asked to take a square root of a negative number. And this number in here is called the discriminant. A little bit more about that later. Thanks for watching. I know this was very long. I'm proud that you've stuck it out to the end. But factoring and quadratics and the zero product property, it's quite intense. There's a lot of moving pieces. So just our goal is to find the roots and to be able to plot them on a grid. Thanks so much for watching.